Okay, here we go. We're talking about quantum mechanics or math with small numbers. So we're talking about electrons, little balls of negative energy, and where to find them. So we devised a category system where we can locate each one based on the probability, likelihood of finding it. So that's like the basis of what we're talking about. So before we taught a nucleus that was positive and was surrounded by these different orbitals. And these orbitals are labeled as n equals 1, n equals 2, and n equals 3. Each orbital has a different energy. It has more energy out here and less energy in the middle. We know that because positive is attracted to negative, and the electrons are negative, the nucleus is positive. And as this distance gets farther away, it has to be stronger to get it. So this distance here, as it goes up, the energy to keep it there also goes up. Okay, so we know that n equals 1 has less energy than n equals 3. We also know that we can move electrons from the inside to the outside by adding more energy, indicating that the second energy level is more stable for more energy than the first, and so on. Well, that's great for like 2D, but 3D, where you have a three-dimensional axis, there's not so much circles. It's spheres. So if that's the nucleus, here's one sphere, here's another sphere, and here's another. So instead of using circles, we're going to use spheres. Spheres show that, we're having different little area for the location of the electron. So we can move an electron from, say, the first sphere to the second sphere by adding energy. As you add energy in, we can move electrons up to different levels. So this is what we consider an orbital. It's not so much a circle. That's kind of what we use as a model. But in reality, it's a three-dimensional area or a sphere that has volume that we need to find the electron in. So, our whole point of this, electrons, and we're trying to find out where they are, where they're located. So let's talk about the four variables of quantum mechanics. We have N, L, M, and S. N stands for the row number. It's also the principal. They go from 1 through 7 because there's 7 rows on the periodic table. Each row has more sequential energy. L stands for the shape of the electron cloud. Electron cloud is what we consider the volume of the orbital, what we just referred to on the last slide. This has numbers of 0, 1, 2, and 3, and they stand for S, P, D, and F. Those are abbreviations for the numbers. We'll use them interchangeably. But 0 stands for S, 1 stands for P, 2 stands for D, 3 stands for F. M stands for the axis. Now we primarily usually only have 3 main axes. So S kind of locates at the origin. P has values from -1, 0, and +1. D, -2, -1, 0, 1, and 2. And F, -3, -2, -1, 0, 1, 2, and 3. Notice we have one location here at the origin, 3 locations here for P, 5 locations here for D, and then 7, 1, 2, 3, 4, 5, 6, 7 locations here. S, and by locations I'm referring to each value. S stands for spin, and we can have 2 values. We can have a +1/2 or a -1/2. Each electron shows that it's spinning one direction. So electrons can spin up, or we can have electrons that spin down. Sorry for the penmanship. So what does that tell us? Well, that tells us that in each of these locations I can fit 2 electrons, because when I add +1/2 plus a -1/2, that equals 0, and that means that it's stable or unreactive. So each of these boxes, each of these locations can fit up to 2 values of different electrons. Now, every time I draw an arrow up, I'm showing that the spin is going up, or a +1/2, and vice versa. So we have 2 of these arrows on each one of these. So if we went through and counted how many electrons can fit in each box, this one would fit 2 electrons, this one would fit 6 electrons, this one would fit 10 electrons, and this would fit 14 electrons. So those are really, really important numbers. So let's put that in our notes. I'll put it in yellow. Let's see here. There we go. Perfect. So those are our 4 values, and they tell us a few things. Again, just a quick review. The N tells us the row number, or the principal energy level. L stands for the shape of the volume of the orbital. M stands for axis, which tells us this whole junk, and how many values we have. And S stands for our spin. So let's put all of this together into a problem. So if N is equal to 1, L is equal to 0, M is equal to 0, and S is equal to +1/2. That means if I have it on my 3-dimensional axis here, I have a value near the origin in that first level, the first energy level. That L was referring to the S cloud. M is referring to at the origin. And this one's referring to spinning up. So my electron spins up. Therefore, there it is. So that's more or less what it's telling us. It's a way to categorize where the electrons are based on these different values. Now, for example, another way of drawing it is electron box diagram. Now, I'll put 1 electron facing up. Now, comma -1/2, that means I have a spin as well going there. The blue example is the example for hydrogen. The red example is the example for helium. Now if you count the electrons for hydrogen, I have 1. Count the electrons for helium, I have 2. They're both in the s orbital. They both fit in the same electron cloud. They both go different ways. That's how this whole phonetic thing works. Okay, I'm going to pause that video for right now. I'm going to come back and we're going to talk about M in more detail. All right, if you have any questions, come see me in class. Otherwise, I hope this wasn't too confusing, and hopefully it'll help you with your homework tonight. Have a great night.